Okay, now we go for the first question. Explain what is difference between gauge pressure and absolute pressure. The answer is absolute pressure and gauge pressure. Absolute pressure relative to the absolute vacuum. Both relate to the atmospheric pressure and use absolute zero as its 0 point. And then for gauge pressure relative to the atmospheric pressure relative to absolute vacuum, you use atmospheric pressure as its 0 point. Now for question 1b, figure 1 show the pressure at set on several points under given fluids PA, PB, PC, PD, PE, PF, and PG, which underlies on the same horizontal line. Position of P1 is the same in horizontal line with PH. However, given that PH not equal P1, explain what the cause the inequality PH not same P1. Use your own dimension, evaluate the PH and P1. Okay, now let we move for the answer that question. pH not equal to P1. Pressure at the point H and I are not the same since these 2 points cannot be interconnected by the same fluid. pH Pi is equal to another pressure that same in density. The pressure force exerted by fluid is always normal to the surface at specific point. As we can see at the figure, Rho for pH is mercury and rho for I is water, and we assume that rho for H is 13950 kilogram per centimeter cube, and then for rho for water is 1000 kilometer per centimeter cube, and we use formula rho GH to find pH, pressure at H, and we might multiply rho and specific gravity, and then height, and then we find rho GH P at water, and we multiply rho G and H, and we get the answer. And then this is to prove that pH not equal to Pi. And then the another another answer is pH is mercury and not equal to water. That's okay. Let's continue. For question 4, for A, what is the evolution description for fluid motion? How does it differ from the Lagrange descriptions? And then for B, compare whether the Lagrange method of fluid flow analysis is more similar to study of a system or a control volume. Okay, for answer for question 4A, in the evolution description, a flow domain or control volume defined through which fluid flow in and out. We define field variables which are function of space and time. For example, the pressure field is a scalar field variables. The difference between these two descriptions is by imagine a person standing beside a river, measuring its properties. In the Lagrange approach, he throws in a probe that moves downstream with the water. In the evolution approach, he across that probe at a fixed location in the water. Furthermore, experimental measurements are more suitable to the evolution descriptions. However, the equation of motion of fluid flows in Lagrange descriptions are defined Newton's second law and but need to be careful in the evolution description. Okay, for answer for question 4b, The Lagrange method of fluid flow analysis is more similar to study of a system. This is because its approach is in effect study of a system where the system is essentially some specific fluid particle motion of which we track. In the control volume analysis, mass in the system is in contrast not fixed. Okay, let's go for the last question for 4C. A garden hose attached with a nozzle is used to fill a 40-liter bucket. The inner diameter of the hose is 2 cm and it's reduced to 0.8 cm at the nozzle exit. It takes 50 seconds to fill the bucket with water. Assume that water to be incompressible, the flow through the nozzle is steady and there is no waste of water by splashing. Okay, now for answer for 4C1 is volume flow rate and mass flow rate. V is equal to 40 liter, D is 2 centimeter and 0.8 centimeter. Time is 50 seconds and rho is 1000 kilogram per meter cube. How we want to find the volume flow rate? We use formula volume flow rate is equal to V over T. So we get 40 liter divide by 50 seconds and we get the 0.800 liter per second for volume flow rate. And then we want to find the mass flow rate. We use formula m dot equal to rho v dot. So rho we change unit to to kilogram of per liter and we multiply by volume flow rate that we get the answer just now is 0.800 liter per second and we get 0.800 kilogram per second. Okay, now the last is to find the average velocity of water at the exits. Average velocity is for formula average velocity is V average equal to V dot volume flow mass divided by A. A is equal to area pi d2 over 4. And then we get for value for A is 0.5027 multiplied by 10 negative 4 meter 2. And then we substitute the value of V dot and the A and we get answer is 15.91 meter per second for average velocity. That's all for me. Thank you.